out.
Let's see, this meeting is being recorded. The account owner can also watch this recording and store in the cloud. Yeah, it looks like it.
Okay, perfect. Thank you so much. And welcome to our weekly SpaceGeekSpeak. It is our pleasure to have Ben and Phil from Artemis Mission Planning Team, and they will be presenting today the effort that is going on with this Artemis 1 and forward. And of course, we're in anticipation of Artemis 1 launch next week. So we are rooting for success. And with that, thank you, Ben. Thank you, Phil. Please take over.
Thanks, Solana. All right, I will share my screen here. I got some charts for folks here. Give me 1 second. All right. Hopefully folks can see my screen.
Yes, we can.
Okay, great. Again, my name is Ben Stahl, and we've got Phil Curell on as well. We are both members of the Exploration Mission Planning Office at NASA's Johnson Space Center. I wanted to thank you all for your time this morning. We're going to give you a little overview of Artemis, the Artemis campaign that we're working towards, and a quick summary of the Artemis 1 mission, which should be launching next week. I've got my coffee in hand as well. I'm in Houston, and we've got our first cold snap overnight, so I've got my beanie on to stay warm. Probably not as cold as Tucson, but plenty cold here. And I'm an iced coffee drinker, so even in cold weather, I've got an iced Americano here. So good morning to all. Thanks again for your time this morning, and we'll go ahead and get things started here with a quick video. And there might be someone that has it. Looks like.
Oh, yes. No, metido bien.
We are at Kennedy Space Center. Every piece of hardware necessary to return to the moon is now here.
They are being assembled, stacked, fueled, and primed for flight.
Next time these engines fire up, we'll be on the launch pad to send an uncrewed Orion spacecraft around the moon on a flight test for the Artemis 1 mission.
It's been a journey of 1,000 miles from factory floors all across this country and around the world to here. And now the stage has been set.
We are seeing Artemis take her place.
The framework to support the enormity of this moment can't be measured in renovations and rehearsals alone.
But in the testing of a metal found much deeper.
With each segment built upon the one before it, the volume of anticipation can be seen rising.
For in addition to certifying what a host of testing has already previewed,
and liftoff. The dawn of Orion and a new era of American space exploration.
Artemis will demonstrate a new path to the moon for this generation.
Artemis 1.
An uncrewed test flight will be a final proving of every system
in every component
in the harshness of space.
A mission that, when successful, will open the door for the moonwalkers and lunar experiments
that so many have hoped and dreamed about.
We are going.
Woo. All right, so Artemis, like we kind of led off with, Artemis is the name of this long duration campaign that NASA is pursuing here. That is our next pathway to getting crew back onto the surface of the moon, and with extensibility to eventually flying crew to Mars and getting to the surface of Mars. Artemis is the Greek goddess of the moon in Greek mythology, and this campaign is going to be our pathway to getting the first woman and the first person of color onto the moon, and that'll happen as soon as Artemis 3, which we'll get into as we're kind of walking through the mission architecture here. So again, I kind of mentioned the extensibility of what we're trying to do on the surface of the moon to Mars. A lot of the architecture that's being put into place in the Artemis campaign and with our early Artemis missions has a multi-purpose capability or extensibility in terms of technology development that's going to pave the way for us getting to Mars and getting to crew on Mars and sustain life on Mars, the end goal. So a lot of the key pieces of the early architecture, including the gateway, which we'll talk about in a little bit, and a lot of the surface assets that we intend to fly and utilize in Artemis on the moon, will be, again, paving the way for what we need to have in place for moon missions to Mars. So that includes exploration on the surface, power generation, in situ resource utilization, operations in partial gravity, life support systems, habitability systems, many different systems that we know we're going to need for Mars. We're going to be utilizing very similar systems in the moon-based missions early on in the Artemis campaign, with that far-off goal in place of eventually getting crew to Mars. So talking about the initial campaign for Artemis, this chart summarizes our first few missions. So starting off with Artemis 1, obviously launching Tuesday night. That is our first uncrewed flight of Artemis, and that will utilize the Space Launch System, the SLS Block 1 vehicle, and the Orion vehicle in that uncrewed test flight around the moon. We'll get into a little bit more detail on that in future slides here as well. Our first crewed mission is going to be Artemis 2, and that'll be a crewed mission to lunar orbit, utilizing the same vehicles that we have for Artemis 1. Artemis 3 will be our first mission that actually goes down to the surface of the moon and takes crew down to the surface of the moon. So we'll be relying on the Human Landing System, the HLS, delivered to lunar orbit before we get there in Artemis 3. And in parallel to that, we're also working on the gateway elements, which are a sequence of vehicles and modules similar to the International Space Station, but instead of being in orbit around the Earth, we'll be in orbit around the moon. And so that will be our science and our habitability center orbiting the moon eventually. And so in parallel to getting ready to fly crew on Artemis 3, we'll be developing the architecture for the gateway, and those elements will start getting deployed ahead of Artemis 4. And eventually, once we're past that initial campaign for Artemis, those are really missions that are intended to build on one another piece by piece. Each mission's adding new capabilities. Each mission is adding new components, new elements, and new assets really to the mix, increasing the complexity of those missions and increasing the value of those missions in terms of the science they can return to the U.S. and really to the human race. And so once we've gotten through the first few of those missions, the first several, we're going to start our sustaining campaign, where the intent is to really start building up the infrastructure on the surface of the moon for prolonged presence there. Our first Artemis 3 mission down to the surface will really just be getting astronauts down there, performing some extravehicular activity, and spending on the order of a week down at the surface. As we get into the sustaining campaign, we're going to be flying additional elements, things like the Lunar Terrain Vehicle, pressurized rover. We've got some new companies on contract to provide EVA suits as well. And the hope is that at one point we'll be moving from that week-long or so mission into like many weeks, on the order of a couple months, as we get further into the Artemis campaign, where we can really practice having sustained life on the surface of the moon, really for the first time. So that's kind of the further off goals for Artemis and what we're intending to accomplish with the Artemis campaign as it relates to the moon. And I should mention, Phil, jump in if there's anything additional to add as I'm running over here. I know that Svetlana said, well, we'll hold questions till the end, which works perfect, but I'm glad to fill in any details that I'm perhaps glossing over along the way.
I was just going to mention that the initial campaign, like you described, helps us get to the moon, prove we can do that. And then the sustained campaign is really focused about practicing what we need to do to get to Mars. So remember, it's all about Mars forward. So everything is focused on developing that kind of technology and proving we can do that on the surface of the moon before we take that big step to Mars, which is much farther away, both geographically speaking, as well as duration.
Thanks, Phil. All right, so where are we going on the moon? If you recall Apollo and the surface missions that were planned for Apollo, most of those were headed to areas around the equator of the moon. They were equatorial based sites because those are easiest to get to. We're actually targeting in Artemis going to the south pole of the moon, on, around, or near Shackleton Crater, which is shown in a couple different images here, including the size of this crater relative to those that are in Houston, relative to the 610 loop shown at the bottom there. So we're heading to a unique area, a place that hasn't been pursued before in human space flight to the moon, and I've got some reasons why we're doing that on this next chart here. So if you can imagine that being the polar site of the moon, it has some unique characteristics to it. One is that at altitude around that area, you're going to be in pretty constant illumination, given you don't have the blockage of the moon as part of the moon's rotational period. And in the areas that are low-lying, like in these craters, there's areas on this surface that are really permanently shadowed, that haven't seen the light of day. And so there's a lot of very unique science opportunity associated with a polar location on the moon. And that's why for Artemis and for the real inherent drive of what we're trying to accomplish with this Artemis campaign, which is maximizing the amount of science that we can get and benefit from in our trips to the moon, we're pursuing this South Pole area. So with the South Pole target as a great science destination, it also has some challenges to it. I kind of mentioned for Apollo that we flew to the equator of the moon because that's really easiest to get to. You can get on a free return trajectory that kind of puts you in line with equatorial targets on the moon. By pursuing a pole, you actually, you've got to do some plane changes, and you have to utilize a little bit more performance of your spacecraft to put you into a unique orbit that gives you access to those poles. And because of the illumination factor that I mentioned before, when you're there, you're likely to be dealing with either little to no sunlight or a lot of sunlight. So you have to design your vehicle to be capable of and plan for targets that really speak to the capabilities of your vehicle. And the chief things that we're paying attention to are making sure that from a thermal perspective and from a power perspective, the vehicles that we're flying to the surface of the South Pole of the moon work well in the environment that we're targeting. This area also has some rough terrain. There's a lot of craters, there's a lot of surface variability. at the south pole of the moon. And so these are other aspects that need to be taken into consideration when you're designing your lunar lander to head down to the surface. We actually just went through an exercise that wrapped up in, I believe, August, narrowing down the targeted regions around Shackleton Crater and around the south pole of the moon. We're down to 13 sites that we're looking at, 13 regions that we're looking at. We're iterating with the science community on the pros and cons across that set, and that'll be part of future down selection of potential target sites that we'll be flying to for Artemis 3, our first crewed mission to the surface. The other thing to mention on the South Pole is that with that continuous light, you can also opportunistically set yourself up for continuous communication with the Earth, which is actually a benefit to being at the pole there. We're never, if we do it right, we won't ever be in the, we'll always have line of sight with the Earth for the missions that we're targeting and the times of year that we're targeting by being on the South Pole. So yeah, very exciting to be heading to a new spot on the surface of the moon, which has a lot of big advantages from a science perspective that we're hoping to jump into. This video just kind of shows you, I was mentioning earlier, the surface at the South Pole, oftentimes either being in continuous light or in continuous dark. This is a rendering of the period of the day looking at the South Pole, and you can see like within the craters, they are staying in continuous darkness, and on the rims of those craters, they're in continuous light. And this again is can be challenging from the perspective of developing a lander that needs to land in this area, but really beneficial in terms of the science that you can capitalize on and some of the other benefits at being in a polar location from a lander's perspective. All right, so for Artemis 1 and for the mission that we're going to be flying on Tuesday night, I think liftoff is scheduled for just a little after midnight Central Time Tuesday night. We're going to be flying the Orion spacecraft aboard the Space Launch System and launching from the launch pad at Kennedy Space Center that's managed by the Exploration Ground Systems group. And I'll touch on each of these vehicles, each of these programs in the next couple charts here. So Orion is a vehicle that folks may have heard of previously. This is a vehicle that we've been working on for a while now and been working on in tandem with both ESA, who's developing the service module for this vehicle, the kind of the propulsive main element of the vehicle, and working with Lockheed Martin and with the NASA team on the crew module, which are both shown here. So the crew module is where our crew of 4 will hang out during launch and through their trip out to the moon and back. The service module just aft of that in this picture again is being developed, built, and delivered by ESA as part of this international campaign. The launch abort system is a solid rocket motor system, somewhat similar to what was utilized for Apollo. That sits atop the crew module and is there in the event of an anomaly during launch that requires, essentially the ejection seat of the crew module away from the launch vehicle to protect the crew in the event that we have an issue during launch. That launch abort system actually jettisons as you get exoatmospheric after you leave the atmosphere. During ascent, and is only utilized or only needed really for that small portion of the flight. And so on the trip out to the moon, it'll be the crew module and the service module that head out there. And how do we get those things into space? That's aboard NASA's Space Launch System. This rocket is the most powerful rocket that has ever been developed and has on the order of 8.8 million pounds of thrust. Which puts it just a little bit above the Saturn V rocket from the Apollo era. More thrust than the Falcon Heavy rocket as well. This is a very large rocket with a whole lot of capability. We're going to fly. The next next chart's got the, yeah, so this is the overall vehicle architecture there. This actually includes Orion in this imagery here, but it's got a huge core stage with 4 RS-25 engines on it, 2 5-segment solid rocket boosters, and a lot of that architecture is very much shared and learned and developed from the space shuttle capability. A lot of these vehicle elements look somewhat similar to shuttle because they were derived from them, and we're kind of utilizing that heritage to make sure that we've got a safe and reliable design for SLS. So above that core stage, you've got the ICPS, the Interim Cryogenic Propulsion Stage. This is the Block 1 version of this vehicle. So that ICPS is what we'll be flying for the first few flights before we swap to an even larger upper stage for some of the further off missions. And then you can see Orion aboard or atop the ICPS here. And then I mentioned exploration ground systems. This is our entire spaceport infrastructure at Kennedy Space Center. So exploration ground systems manages our vehicle assembly building, where we're going to be integrating these vehicles together, where we've already integrated the Artemis 1 vehicle before rolling it out to the launch pad, which EGS also manages. They manage the crawler. All of the vehicle integration, all of the launch operations are all run out of Kennedy Space Center by Exploration Ground Systems. So it's really these 3 programs that are working together to execute the Artemis 1 mission from initial development through actual launch and recovery. So once we get a little bit further into our Artemis campaigns, I mentioned the Gateway previously as the ISS type vehicle that'll be orbiting the moon. This is the latest rendition of what that vehicle will look like, which includes several elements that'll be flown incrementally as part of the Artemis campaign. They've got a power and propulsion element, a few habitation volumes for the crew to reside in, and additional elements, some of which are internationally developed, will be flown as well. And then you've got the Human Landing System, the HLS. So this is a program that has picked up SpaceX actually as our initial provider for HLS. And so on Artemis 3, our first flight to the surface of the moon with crew, that will be done with SpaceX's Starship, which is still in development, and folks may have seen a lot of their initial testing. So we're working very closely hand in hand with HLS and with SpaceX to develop those capabilities, relying on lessons learned based on our NASA experience, and helping them develop a safe vehicle, a reliable vehicle that we can bring crew down to the surface of the moon with. And then the final piece of the puzzle I kind of mentioned earlier, and that's really getting to the point where we've got this Artemis Base Camp. We have a newly stood up program at NASA, the EVA and Human Surface Mobility Program, which is really responsible for the development of these assets for use on the moon. And that comes down to making sure we've got a good surface habitat for the crew to reside in, a pressurized rover for navigating the surface, an LTV, a lunar terrain vehicle for maybe further off ops for suited operations with our crew, comm, navigation, and power solutions for the surface, in situ resource utilization. All these things fall under the purview of that EVA and Human Surface Mobility Program. And so they're working on the initial plans for all of these aspects to support those further off missions and to support that end goal of sustained life on the surface of Moon, again, on the path to eventually extending that out to Mars. So a little bit more on Artemis 1. Artemis 1, again, is our initial mission here that's going to be flying this week. The key aspects that we're trying to demonstrate and prove out on Artemis 1 are demonstration of the Orion heat shield at lunar reentry conditions. That is one of the most challenging technological aspects of spaceflight, and particularly spaceflight to the moon. Orion actually did a exploration flight test several years back to do initial testing on the heat shield. I think they got upwards of 20,000 miles per hour prior to reentry. And I think for Artemis 1, we're looking more like 24,000 miles per hour. So a little bit more stressing case on the heat shield. We're trying to demonstrate the Orion systems in a flight environment. So this mission will be on the order of 3 or 4 weeks long, could be upwards of 6 weeks actually, kind of depending on when the date that we actually launch. I think with our launch opportunity Tuesday night, it's something like 3.5 or so weeks. But that'll be a complete capability to prove out the Orion system with long duration space flight. We're going to practice retrieval of the spacecraft, which will be splashing down off the Pacific coast. And then completing secondary objectives on checkouts of the vehicle and some of the external payloads that we're also including in this mission, CubeSats, pressurized payloads that are additional science demonstrations that are part of our goals and our utilization of the Orion and the mission profile that we're flying here. So the next few charts here are they're essentially, we call them mission maps. And so with Phil and I and the mission planning and integration roles that we have for NASA, we help, one, integrate across all of the elements that I've kind of described today, making sure Orion's working well with SLS, which is working well with the human landing system folks, and stitching all of that together. So part of our role is to make sure that all of the constraints on each of these programs, on each of these elements, are satisfied such that the mission can actually be performed end to end, and then work on ways to represent that so that in as little as a single chart like this one, you can get a pretty good feel for what we're trying to do here. So I know there's a lot of words on this chart, and I think I'll get with Svetlana after the meeting today to see if we can get these out there for you guys if anybody wants to take a look at these and kind of dig through them a little more deeply. But this is the end-to-end mission for Artemis 1. So Artemis 1 is going to be launched from Kennedy with Orion aboard the SLS, the Block 1 version of the SLS. We will utilize the ICPS to perform the translunar ejection burn, which is the big major propulsive burn that sends you on your path to the moon. Then we'll jettison that ICPS, and Orion will do all of the maneuvers on its own with the service module from there. We'll enter into a distant retrograde orbit around the moon and orbit the moon for a little bit before performing a powered flyby of the moon, and then heading back to Earth, and all of that will be controlled by the Orion spacecraft. We'll jettison the service module once we're in low Earth orbit, just prior to returning and going through entry, descent, and landing off the coast of California. And this mission will be, again, on the order of 3.5, 4 weeks. End to end, and should be launching on Tuesday night. So that is Artemis 1. I've got follow-ons for the additional Artemis flights, and I'll kind of talk about, again, that incremental approach, that building upon one another approach that we're executing for this Artemis campaign. So Artemis 2 is a big step. It's the first crewed flight and the first crewed flight to the moon since Apollo. So for Artemis 2, building on Artemis 1, we'll be flying Orion aboard SLS once more. We'll use the ICPS to get us out to a high Earth orbit, and we'll perform a proximity operations demonstration to really prove out Orion's capabilities to do proximity operations and essentially be planning and leaning forward to our plans for Artemis 3, when we're going to need that vehicle to be docking to the human landing system in lunar orbit. So we're going to get to do a lot of that practice with the ICPS and with Orion on Artemis 2. And after that proximity operations demonstration, we'll utilize Orion to perform the translunar injection burn. We'll fly out to the moon on a hybrid free return trajectory, orbit the moon, head on back, and bring the crew back to the surface of the Earth, and have splashdown off the coast of California once again. This mission is slated for sometime in 2024 timeframe, and it's on the order of 9 days or so in total duration, end to end. So a little bit shorter mission with this free return trajectory, or hybrid free return trajectory. Artemis 3 is our first landing on the moon. So this is obviously a big one, a key one, and one that we're hugely excited about. So the big changes here for Artemis 3 are that we will be going into a near rectilinear halo orbit around the moon. So instead of the distant retrograde orbit or the free return trajectory that we're on for Artemis 2, this is a stable orbit around the moon that is fairly eccentric. If for folks that are follow the orbital elements of orbits, this one is certainly unique and very highly eccentric, meaning it really varies the distance that you are from the moon greatly throughout the orbital period. It's a stable orbit that doesn't require a lot of propulsion to keep you in that stable orbit, which is why it's being targeted here. And so for Artemis 3, we will launch the human landing system, the HLS, from the Earth before we launch the astronauts on Orion. We'll get that HLS out there into NRHO, that near rectilinear halo orbit around the moon, and then we will launch the crew, knowing they've got a destination vehicle to go rendezvous with in lunar orbit. So we'll rely on SLS and Orion once more for this mission. And we'll utilize the ICPS to perform the translunar injection maneuver. Orion will fly out to NRHO, dock with the HLS. A couple of our astronauts will board HLS and take that down to the surface of the moon and spend on the order of a week or so down at the moon before they ascend and redock with Orion. And then all 4 crew will pile back into Orion and fly Orion back home to the Earth from there. Artemis 3 mission is on the order of 3 to 5 weeks long in duration, kind of depending on what launch opportunity we take. And again, that surface mission should be on the order of 6-7 days, somewhere in that time frame, and includes some extravehicular activities, some spacewalks, some lunar walks with the crew that's there. Artemis 4 adds yet another component to the mix by delivering the IHAB, the International Habitation Module, to Gateway. So this mission will be unique in that we're going to pre-position some of Gateway. So this will be the first mission where we're headed out to see the Gateway space station orbiting the moon. We've actually added back the capability to perform a crewed lunar landing as part of Artemis 4 as well. So it's essentially Artemis 3 plus Gateway. We'll be flying on the larger version of the SLS with the exploration upper stage. And that will have an additional habitation module payload, the International Habitation Module payload, that will fly on SLS as well. So Orion will essentially tug that new module out to NRHO, that same orbit that we fly on Artemis 3. Bring that up there for Gateway to again to keep building on the architecture of Gateway. We'll have HLS involved as well and perform another a lunar descent and a lunar landing, again on the order of 7 or so days for Artemis 4, but we'll be utilizing in orbit around the moon, not just HLS and Orion, but also Gateway. And then Artemis 5 is kind of continuing to build on Artemis 4. So similar profile to Artemis 4, includes a lunar landing, has an additional payload with Orion on SLS, which is the Esprit module, which is a capability that's actually being developed by ESA as well. It's a communication and habitation and fuel module, essentially, that will increase the capability of Gateway. So that will be flying aboard Artemis 5 as the co-manifested additional payload to the crew for Artemis 5. So yeah, that's the initial campaign architecture. This is the set of missions that kind of sets us up to have that sustained presence on the surface of the moon, starting with having sustained presence in the orbit around the moon with Gateway. So these are the missions that kind of pave the way, that get us on track to getting humans back to sustained presence on the surface of the moon, learning a ton about how to do that, how to live in that environment, and then how to feed that forward to how we'll be working on getting crews to Mars in the distant future. So I've got one more video, I think, to wrap up that dives a little bit deeper into to Artemis 1. So I'll play that now.
3, 2, 1, 0. Mission liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program. And there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there in the next couple of decades.
All right, so for those that utilize the socials, at NASA Artemis, you can find us on Twitter, you can find us on Facebook, you can find us on Instagram, and at nasa.gov/Artemis for all the latest updates. And I think that's all we had for today, and glad to take questions. Phil mentioned that we did have some questions perhaps related to SLS in the chat. I have not seen the chat yet, so Phil, if you want to take the initial stab at those questions, glad to let you.
I'll go ahead and read them. So the second one, I have to scroll to the top, but the second one is, why does NASA continue to tout SLS as the most capable rocket ever launched? The Block 1 SLS can only send 60 pounds to the moon, and the fully evolved Block 2 crew SLS is only expected to send 95 to the moon. A fully evolved Saturn V actually sent over 100 So our thoughts there?
Yeah, I'm not an SLS guy, and no, Phil isn't either, but I think that vehicle is being designed for the capability that we need and the capability that we require. It probably is a little bit of a nuance the way that it's described as the most powerful rocket. That's probably just from a thrust perspective, not necessarily from an overall capability perspective. So understood on the thought. It's just the vehicle, at least from my vantage points, being designed to satisfy really what the needs are of this architecture and of this campaign.
Yeah, and if you're looking at the rockets across the board today, that it would be the one that is the most powerful in use right now.
Sure.
Hey, another question came up. Why do we do a nighttime launch for Artemis 1? I can feel that one. There's lots of launch constraints that go into a launch availability calendar, which we develop for each mission in its campaign to launch is heavily constrained by where the moon is relative to the Earth. It's also, there's different eclipsing conditions that can occur as the vehicle is outbound and coming back. There's power limitations there for the arrays and batteries. If you're adding in a landing, which this first one isn't, but of course, if we add in a landing, then you want your landing mission, your week-long landing mission, to be in the proper lighting conditions that's conducive to doing the best exploration and science and whatnot. So there's a lot of launch constraints. So what you have sometimes are these night launches. In this case, sometimes, like the previous launches were daytime. These next few in this launch period a lot of them are at night. And what's really cool about the night launches is you can see the rocket a long way. If you're at the pad, you can see it a long way through its ascent trajectory. Whereas if it was daytime, you'd lose sight of it pretty quick. So if you're down at the Cape, it's a perk to have a nighttime launch.
Thanks, Phil.
Oh, can I come in on that, Phil? I understand there's a lot of constraints and requirements for the launch, but I know that launch windows to go to the moon typically have two availabilities. One is at night and one is at day. And I would think that the daytime launch would be much preferred because, especially for the first launch, it is really a public observation, and the public would have a greater view and chance to view it in the daytime, as opposed to 1 o'clock in the morning. And so I would think that would have that factor would have a bigger factor in picking that launch window.
Yeah, I agree with you about the engagement with the public. That makes total sense. But there is in this case, this launch period doesn't have the daytime launches. So, as you know, there's the weather that throws a monkey wrench into our plans sometimes. So really, we'll take whatever launch, whatever the launch window can provide, and try to make this launch happen.
Oh, so do you know
that all factor into what the mission availability looks like? And there's so many things we have to satisfy. I think we're trying to make sure that when Orion comes home, we get splashdown during the day to help make sure that we can really look at that heat shield and get good data on it post entry, and also the parachutes. And there's just so many things that factor into the availability windows that we have. And some of those are less conducive to being like in prime time, and less conducive for our launch teams in terms of all the sleep shifting that they'll have to do. But it's kind of the nature of space flight to have to weather those things. So
if I could break in with another answer to Mike's question, it's immediately in the flight profile, you have to satisfy range safety. Okay. And on these days, connecting the launch site with the moon in a efficient trajectory, the 2-hour launch window that satisfies range safety constraints, because the azimuth that you launch into out of the Cape is constantly changing with time, right? And at best, you have 2 hours, and those 2 hours fall at night on this date.
Yeah, most of our launch windows are about 2 hours or less.
Or less.
Most of them. Yeah.
Yeah.
Yeah, the one on the 14th, it was only like 69 minutes. So, but yeah, good point.
Yeah, I was asking why did that launch window not open at the range safety opening constraint? And I got word from JSC that it's because the Orion spent too much time in Earth's shadow on the way out to the moon. So there's all these constraints like you guys cited.
Yeah.
It's just one thing or another.
Yeah.
Okay.
And
Okay.
I don't know. Yeah, and Apollo was a different vehicle and it had different constraints.
Mhm.
So sometimes you might get those, 2 launch opportunities in a given day. Might turn out that way.
Okay, thank you, Dan and Phil.
Any other questions out there? Thank you all again for hosting us today and allowing us to catch you up a little bit on the plans, latest plans for Artemis. It's been great to share this and broadcast a little bit and have coffee with you guys this morning.
Thank you.
Thank you. And
Thanks,
Dan, I don't
folks.
know if you were able to get on, or sorry, not Dan, Dave, to get on to, I don't know if there's a closing discussion or anything. But yeah, I think that's all we had for today.
Yes, hi. I actually have one more question regarding the Van Allen belts. I recently read that it could be a very good orbit to translunar injection burn if you do it from a polar orbit. Of course, this would take a bit more delta V, but you would avoid large parts of the Van Allen belt. Is that? Do you have a comment on that? Is that something that could be done in the future, or?
That is beyond my expertise for certain. I think you're stating it's easier to potentially depart from a polar orbit at around the Earth to head like before TLI.
Yeah, exactly. So that you basically would avoid the belts and the equatorial parts.
Yeah, I think the challenge of getting into a polar orbit around the Earth from a performance perspective on SLS would be hugely challenging. I don't know if that was in trade space at one point based on the avoiding that Van Allen belt or not. But yeah, that would be my initial thoughts anyway, a little bit uninformed. So I don't have a better answer for you there.
All right.
Yeah.
Thank you.
Yeah, I would add that just plane changes are expensive, very expensive, fuel-wise. So whether it's the initial plane change, if you will, off the planet's surface, as well as while you're in orbit, wherever you're doing it, it's very expensive.
Oh, I thought maybe because we basically, since we're heading for the poles anyway on the moon, it might not have zeroed, but okay. Yeah, but thank you.
Yep. Works against you in this case.
Thanks, everybody, for the good questions. This is Dave. Sveta and I are really appreciative of you guys explaining all these things to everybody. It's been really exciting hearing about where we're going now with Artemis. And in particular, I hadn't heard that much about the 4 and 5 missions. That was really good to hear what the planning is going on for those. And so this is great. And we appreciate your taking your time to join us today. Any other questions from folks out there?
Yes, I have a question.
Yes.
Okay.
What makes a good weather, like night or day to launch?
Yeah, from a weather perspective, it's really more about the weather systems that you're dealing with. rain, precipitation, winds are key drivers, and lighting is not a huge driver, at least for launch. So night is actually oftentimes better from a weather perspective because you can get a little bit calmer wind patterns overnight, but that's not universal. So.
Yeah, that's a good question, asking about the weather. Very good.
Yeah, no hurricanes. No hurricanes.
Yeah, that's also a good thing.
2 of them this time. It's crazy. Somebody asked about mission durations, and I'll answer that really quick. If you're talking about total mission duration, they're generally around 30 days. But if you, but it's really largely dependent on what you're doing during that whole mission. If you have a surface mission also, or if you're going to Gateway and you're hanging out there for an extended period, that 30 days will grow to like 60 or whatever. But what we're looking at on the surface is initially about 6.5 days on the surface. And then longer term, we're looking at more like 30 days. And eventually, well, that's an eventuality. We need surface assets to support that. And Ben did have a slide that kind of showed the other surface assets that would be there to support something like that. That's a sustaining period. But that's the general answer there. As far as like number of crew, it'd be 2 crew down to the surface at first, while the other 2 stay in orbit around the moon in NRHO, which is the lunar orbit. And eventually all 4 crew would go down to the surface for those longer duration missions. Hopefully that answers the question.
Again, that's great info. Yeah, it's just so exciting how we're going back to the moon and as often as stated, going back to stay and doing it internationally. So it's really exciting. Okay, so I'll go ahead and stop the recording here now, and everyone will be able to get this on our YouTube channel.